does is increases the pressure. And it's that increased pressure that makes it go this. By the way, is this a gas or a diesel engine? How do we know it's a gas engine? There's a part on a gas engine that is not on a diesel engine. I mean, they pretty much look the same, except there's one thing on this picture that would not be on a diesel engine. Spark plug. Gasoline engines need a spark plug. Need a spark plug to ignite the fuel-air mixture. Now, gasoline does have a more energy in it. That's why we use gas engines. Gas engines have much more energy to them. There's much more energy in gasoline. It's much more volatile. However, diesel engines have a much higher pressure. They pressurize this fuel-air mixture to a much higher degree, much higher pressure, and the fuel-air mixture will ignite itself. In other words, as you increase that pressure, remember you do the work, the temperature goes up. Temperature will get up to a point where the diesel mixture will ignite and it'll go down. In fact, when you have like leaks like oil, if oil gets in your valves and you turn off the car and your car just keeps running, we call that dieseling. Gasoline engines, great, a lot of power, things like that, but they don't have best mileage for big applications like big trucks, things like that, diesel ships. If you don't have to go anywhere fast, diesel's great. If you wanted to go faster, want a lot of acceleration, gasoline does a much better job on that. And it used to be people bought diesel engines on cars. Why people have diesel engines? Because it was cheaper. They do get better mileage, but diesel costs a lot more than gasoline these days. I'm not sure what the break even. It used to be diesel was cheaper and you got better mileage. But then again, the difference in price, a friend of mine who was a marine engineers deal with propulsion plants. They design the propulsion plants on ships. The idea is a design study. Volkswagen diesel rabbits were the big thing back in the 80s. Get a diesel rabbit. Volkswagen. But they decided, what's the difference? The difference in cost between a gasoline and a diesel engine, cost you more for a diesel engine. In order to break even for your fuel costs, you had to drive the car 300,000 miles. So you had to drive that car 300,000 miles. How many of us have cars that we've driven 300,000 miles? Your parents have cars 300,000 miles? Not many. Trucks, big trucks do that. You mean 100,000 miles on a big truck in a year? That's like nothing. Million miles, millions of miles in the lifetime of the truck. So diesel's not always the best option these days. But on this, basically what happens is you have a isobaric. In other words, pressure stays the same. We're open to the atmosphere. Our working fluid is... By the way, what do you think the working fluid of a gasoline engine is? Or even a diesel engine? Gas or air? Air. Air is the working fluid of your engine. Draws air in from the atmosphere, and we go down. The piston goes up. We do work is being done on it. Increases. And then we compress. Basically, we have adiabatic. This is adiabatic process. The temperature is going to go up. We get to the top. We ignite. And the reason you ignite it is to make the gas really, really hot. Basically, increases the pressure a lot. And since it's a pressure a lot, it wants to expand. And when it expands, it pushes. It does work on the piston and goes down. And then we expel it back to the atmosphere like that. In these 4 strokes, 1, 2, 3, 4, how much of the time are you actually getting power in the engine? 1 out of 4 times. 1 out of 4. This is why, most engines, the smallest engine you generally see is how many cylinders? Well, on a car. 4, right? So every piston is supply 1. But they're like pretty rough. Which one is smoother, a V8 or a 4-cylinder engine? 4-cylinder engine. The more pistons you have, the smoother your engine is going to run because you're getting power more often, more free. In other words, every 1/8 of a stroke, you're getting power on a V8. Some of these cars, like these big luxury cars, have 12 and 16-cylinder engines, and they run really smooth on that. So, on that sort of thing. So if we look at our little thing here. Come on. Wake up. Doesn't want to wake up today. Okay, doesn't want to turn on today. Oh well, no biggie. We'll show it when it actually wants to wake up. Okay, so a couple of different thermodynamic processes. So that's adiabatic. Another one, isothermal. Isothermal. Why are you just being persnickety? Isothermal has something to do with, it's the recorder doing something. Isothermal temperature change means delta U equals 0. There's no change in temperature, delta U 0. So Q equals negative work. What happens is basically whatever heat I put into the system immediately goes out as work done by the system. If I do work on the system, it immediately go out as heat to the environment. In other words, the energy just passes through the device, isothermal. Really never have any true isothermal steps. In the ideal Carnot cycle, there is part of, which is the ideal engine, which you can't make, of course, because it's ideal. There's two isothermal processes. Isobaric, we don't really have anything here for that. We have isobaric. Pressure does not change. I'm not going to give you a formula for that. By the way, this is yours. Isobaric. Pressure does not change. That would be like the first and last steps of the car engine. So, the car engine. And the last one is an isovolumetric. Volume changes the same. Now, that means work is 0. In order to change volume, we have to do work, which means delta U equals Q. Delta U equals any heat gained or lost by the system. So that's what isovolumetric means. Anytime you change the volume of something, you have to do work. You know, our air expanding in the atmosphere, our piston increasing or decreasing, work has to be done on that. Anthony, with me? All right. So, questions. So next time, second law. Actually, we're going to do lab next time, if I'm here. By the way, have your books ready. My daughter has been sick. Damn it. Yes, sir. No. Has been sick, so she may or may not be here